Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel. Let's look at binocular vision. So, is a vision using two eyes with overlapping fields of view, allowing good perception of depth. It means that you can judge exactly in which distance and how big is the size of an organism using these eyes. So it means that you have multiple images which are being formed, but the brain is supposed to interpret it as one organism or one individual being viewed. So if you look at this, you see that a lot of light is entering with different light rays. But when they enter, because I have one eye here and I have another eye here, it means that I have different images which are formed. One image from this side, for example, and one image from this side, for example. And then when they are being sent to the brain, it is being interpreted as one object. So binocular vision is very important. It's very important in developing good perception, in developing good depth perception, which in turn affects the coordination and the hand-to-eye skill. It means that if you're using two eyes, if you close one eye and then you try to do a target, yes, of, for example, a small hole, then you won't be able to do it. So it means that if you use two eyes, then you can judge the actual distance. For example, catching a basketball, making sense of classroom instruction on the blackboard or screen, and then performing simple tasks such as walking and running. So you require, it means that a person who is having two eyes is more advantageous. So that is binocular vision. So this makes us to go to what you call accommodation. Accommodation, when we talk about accommodation, we don't mean the accommodation where you stay, no. Here is like ability of the eye to see near and far object. So it means that he's supposed to change the focal length of the lens so that it can see the near and far object. So it's the process of changing the shape of the eye lens to focus the near and the far object. So it means that the eye is supposed to change its shape. Basically, the lens is supposed to change its shape so that it changes the focal length. If the focal length is changed, then it means that the distance where the image is being formed it also changes. So it means that now the eye will be able to see the near and the far object. So let's look at the near vision. When you talk about near vision, you're talking about an object which is less than 6 meters from that object. More than 6 meters from that object, then it means that that is a far object. So what happens during near vision? One, there are some muscles which you need to understand in this case so that you can understand how it operates. And then number two, when you are trying to describe near vision, when you understand the near vision, the far vision, it will be just the opposite of the near vision. So there are some muscles which call the ciliary muscles. And then there are other muscles which you call the suspensory ligaments. Then you have the lens. Yes, you have the lens. And then you can talk about the light. So let's try to describe this. So if you say that ciliary muscles, if these are the ciliary muscles, yes, if this contract, then this one must relax or they must loosen. So they work antagonistically in the opposite way. So ciliary muscles will contract. When the ciliary muscles contract, yes, if the ciliary muscles contract, then this one must relax because they work in the opposite way. Suspensory ligament must slacken. It means that they must become loose. And then because they are loosened, then it means that this one, the tension on the lens has decreased. The lens become more convex. It means that light rays are refracted more because it is coming from a big object or a nearby object, so it looks to be big. So light rays are being reflected more, and then the clear image is being focused on the retina. Let me give you an example. If you are viewing an object which is near, so it means that that object, you see it as a very big object. So it means that it will require a big lens, yes, or a thick lens or a more convex lens so that that lens can bend these light rays, yes, which has come with a big field of view onto the retina. So if the lens was small, then it means that that power of the lens is not going to be enough to bend this light onto the retina. Therefore, the lens must be big. So when you're explaining this, how do I know that the suspensory ligament must relax or slacken and then ciliary muscles must contract? If the lens is big, so if you are viewing an object which is near, then it means that the lens must become big. Near object looks big, therefore the lens must be big enough to bend this light from this object. Therefore, if the lens is big, it means that it's more convex, then it means that what is attached to the lens must relax or it must slacken, which is the suspensory ligament. And if the suspensory ligament slackens, then it means that the ciliary muscles must contract because they work antagonistically. From there, now you can start, the ciliary muscles contract, the suspensory ligament becomes slackened. When they slacken, the tension in the lens decreases, the lens becomes more convex, and then the refracting power increases, light rays are bent to the retina more, light rays are being bent more, and then the image, a clear image is focused on the retina. That's how you can try to explain that. Then if you look at the distant object, it's just the opposite of the near vision, more than 6 meters from the object. So in this case, we will see that it's just the opposite of the other one. The ciliary muscles relax, the other one contracted. Then suspensory ligaments become tightened. It means that the other one is slackened. It becomes taut. It becomes tightened, like it becomes stiff. So the other one was slackened, like relaxed. The tension on the lens increases. Then it means that the other one, the tension on the lens decreased. And then the lens became less convex. It means that it became small. And then the other one, the lens became big. If you do the tension on the lens becomes less convex. And if you release the tension on the lens, then the lens becomes more convex. That's how it works. Then you're saying that light rays are being reflected too, are being reflected less. Why? Because the lens is less convex. And then clear image is being focused onto the retina. So this is how it works, that if this one becomes, it relaxes, this one must contract, and then this one becomes, if it contracts, it means that this one is pulling this side, and then also this one is pulling this side, and then the lens becomes small, which means that the lens becomes less convex. And then because it is less convex, thickness is too small, it means that its refracting power is small, is less. Therefore, it means that the light rays are not going to be bent as much as like that one of near object. And that's why when you are seeing the object which is far, you see it as small. Why? The light rays come as a very small beam, and then it is being bent to the retina, and then a clear image is being focused there. So that's how you can differentiate between those two. What about pupillary mechanism?